Hi, in this video we are going to talk about the main difference between AVL trees and red-black trees. So, let's get started. Basically, what about red-black trees? Linux kernels relies heavily on red-black tree data structures because insertion is fast. Because it is not rigidly balanced, we do not bother about making the tree as balanced as possible. We have been talking about that AVL trees are more rigidly balanced in the sense that on every insertion we check whether the tree is balanced or not, and if the haze parameters differs more than 1 or -1, then we are going to make the rotations in order to be able to make the tree as balanced as possible. It is not true for red-black trees. Red-black trees are not strictly balanced. And that's why basically insertion is faster. But it's very important that insertion, so as far as inserting items are concerned, as far as searching for items, it is not true. But as far as inserting items, red-black trees are faster. So for an insert-intensive tasks, we have to use red-black trees. Because we are going to be able to insert items faster than for AVL trees. For example, in Java we have the java.util.tree map or the java.util.tree set that uses red-black trees in the low level. Or for example, in the C++ standard library we have the map, the multi-map and the multi-set, and these data structures are implemented with the help of red-black trees. What about AVL trees? They are rigidly balanced trees and hence provide faster lookups. So for a lookup intensive task, we should use AVL trees. As far as insertion and deletion is concerned, it is not so fast because we keep rebalancing the tree over and over again. So it's very important to see the difference that, okay, because the AVL trees are rigidly balanced, then the lookup operation when we search for a given item is going to be very fast. It's going to be logarithmic. Okay, but because we keep rebalancing the tree on every insertion and we make sure that the tree is rigidly balanced, that's why the insertion or deletion operation is not going to be as fast as, for example, for red-black trees. Because, okay, we come to the conclusion that the tree is a bit unbalanced and we are going to make several rotations to make it balanced. So that's why the insertion and deletion is not so fast. If we have an application when there are several insertions and deletions, then use red-black trees because red-black trees are not rigidly balanced. If we construct, for example, a whole tree-like structure at the beginning and we would like to make several lookups, so search operations, then of course we have to use AVL trees because they are more balanced in the sense that the search operation is going to be faster. Okay, so that's all about the main difference between red-black trees and AVL trees. Thanks for watching.